Now we see about it debate superconductive magnetic balance gravity, levitation balance gravity. Interaction first we say about the interactions. Reduced gravity is known to have important effects on various biological and physical systems. For instance, weightless environment may prohibit cell culture growth one and mainly cause cellular stresses and bone loss that can negatively impact astronauts' health in a flood system. Reduced gravity can significantly affect the slowing dynamics of cryogenic propellants in spacecraft. The surface oscillation of liquids drops, bubble cavitations, and boiling heat transfer in fluids in material science, and potential of reduced gravity is growing tissues and crystals, and for the materials processing has been recognized conductivity. Systematic research to understand the mechanisms of gravity in those system will advance our knowledge. Furthermore, various programs initiated recently by public space agencies and private organizations aiming at long-term human habitations of the moon and Mars have a future centered the needs of experimental research in low gravity environments. The ideal microgravity conditions can be achieved in a spaceflight expectation conductivity during space shuttle mission and at a space station. Magnetic levitation. This article is about the physical phenomena from the form of transiency. Magnetic levitation can be stabilized using different techniques. Rotation is used. Magnetic levitation or magnetic suspension is a method by which an object is suspended with no support other than magnetic fields. Magnetic force is used to calculate the effect of gravitational force and any other forces. The two primary issues involved in magnetic levitation are lifting force, providing an upward force sufficient to contract gravity, and stability, ensuring that the system does not spontaneously slide or flip into a configuration where the lift is neutralized. Magnetic levitation is useful for magnetic trains, complex metallic melting magnetic bearings, and for product display purposes. This is the diagram for magnetic levitation. Some methods levitations and control of 6 axis. A combination of permanent magnetics and electromagnets or the diamagnets or the superconductives as well as attractive and repulsive fields can be used from Einstein's theorem, and lot lost at least one stable axis must be present for the system to deliver successfully, but the other axis can be stabilized using the ferromagnetism. The primary ones used in trains are the servo stabilized electromagnetic suspension, electrodynamic suspension, mechanical concentration with a small amount of mechanical concentration for stability. Achieving pseudocode levitation is a relatively straightforward process if the two magnetic are mechanically concentrated among six signal axes. For example, and arranged to repel each other strongly, this will act to levitate one of the magnetic above the other. Another geometry is where the magnets are attached but prevented from touching by a tangential member such as stringing and cable. Another example is the chip type center figure where a cylinder is suspended under the attractive magnet and stabilized by a needle bearing from below. Another configuration consists of an array of permanent magnets installed in a ferromagnetic U-shaped profile and coupled with a ferromagnetic rail. The magnetic flux crosses the rail in a direction transversal to the first axis and creates a closed loop on this U-shaped profile. The configuration generates a stable equilibrium along the first axis that maintains the contain and the fixed correction point and allows to bear a load magnetically on the other axis. The system is constant represented by mechanical means such as the whales induced currents. These schemes work due to repulsion state to Lenz's law when a conductor is present with a time varying magnetic field. Electrical currents in the conductor are set up which create a magnetic field that causes a repulsive effect. This kind of system typically shows inherent stability, although extra damping is sometimes required. Dynamically stabilized levitation, a permanent magnetic stability levitated between fingertips and Newton's theorem does not apply to diamagnetic stress behavior in the opposite manner to normal magnetic owing to the relative permeability of a torque or less than one. Magnetic levitation can be inherently stable. A permanent magnet can be stably suspended by various configurations of strong permanent magnets and strong dimagnets. When using superconducting magnets, the levitation of permanent magnet can even be stabilized by the small dimagnetization of water in a human. Diamagnetic levitation of prolytic carbon. Dimagnetization is the property of the object which causes it to create a magnetic field in opposition to an externally applied magnetic field, thus causing the material to be repelled by magnetic fields. Diatomic materials causes lines of magnetic flux to curve away from the material superficially. An external magnetic field that alters the orbital velocity of electrons around their nuclei, thus changing the magnetic dipole moment. According to Lenz's law, this opposes the external field. Dimagnetics are materials with a magnetic probability less to zero. Consequently, diamagnetism is a form of a magnetism that is only field. It is generally quite a weak effect in most material, although superconductors exhibit a strong effects. Direct diamagnetic levitation, a leapfrog levitation instant inside a 32 millimeter diameter vertical blue of a bitter so and a magnetic field of about 60 Teslas. A substance that is diamagnetic repulsive magnetic field. All materials have magnetic properties, but the effect is very weak and the issue usually overcome by the object paramagnetic and ferromagnetic properties which act in the opposite manner. Any materials in which the diatomic component is stronger will be repelled by a magnetic. Diamagnetic levitations can be used to levitate very light pressures of pre-light graphite or bismuth. A moderately strong permanent magnet, as water is permanently diamagnetic. This technique has been used to levitate water droplets and even live animals such as a grasshopper, frog, and mouse. Superconductivity is a set of physical properties observed in a certain materials where electrical resistance varies and magnetic flux fields are expelled from the material. Any material exhibiting these properties is a superconductor, unlike an ordinary metallic conductor whose resistance decreases gradually as its temperature is lowered even down to near absolute zero. A superconductor has a critical temperature below which the resistance drops absolutely to the zero. An electric current through a loop of a superconducting wire can persist indefinitely with no power source. A magnet levitation above a high temperature superconductor cooled with liquid nitrogen persistent electric current flows on the surface of the superconductor, acting to execute the magnetic field of the magnet. This current effectively forms an electromagnetic magnet that repels the magnet. High temperature superconductor levitation above a magnet. Superconductivity phenomenon was discovered in 1911 by Dutch physicist Hig Hammerling once. Like ferromagnetism and atomic spiritual lines, superconductivity is a phenomenon which can only be explained by quantum mechanics. Behavior of photons in the magnet for most of them time the flips remaining in constant contact with the walls, floor, and selling of ions in common with the finding of previous studies. The files are alternated between the stationary periods and attractive active periods in which they moved around the arena. A technical problem moving to the slight degrading of the charge coupled device video image in the strong magnetic field prevented us from identifying and the difference in more complex behavior of the files such as grooming or beating. And this nonetheless differences in a walking speed could be observed clearly in three different positions on the magnet. Or it is immediately apparent from the video image that the files in the zero arena walked more quickly and more frequently, although the files did perform short flights. Oscillation in all arenas quite occurred so infrequently in the unbeamed space of the arena that we could obtain no information on the effect of levitations or of a hydrated on a flight. A small number of flips, typically 2 or 4 at any one time, levitation field in the zero arena, not conducted with any surface. These fields levitated within 1 to 2 millimeter of the observed levitation point of water moving to the large water content of this file. Conclusion: we have reproduced and recorded in our laboratory to levitation of magnetic type 1 superconductor by using a simple handheld Krebs-Start, and we have obtained from simple electromagnetism the analytical equation for the equilibrium position. Experiment provides for a visual discussion of the always facing fascinating levitation phenomena. The periodical increments complement popular levitation with type 2 high TC superconductors. Our experiment includes the thermodynamic and theoretical electrodynamics. Thank you.